43. It is hot in London. Not often you get to say that. It is hot in London, enjoying the weather. Now let's have some fun with the problem solving. I hope wherever you are in the world that the weather is great, and I hope wherever you are in the world, that you're managing to get on. We got the situation that's going on, but I hope everything's okay. And we're gonna start. Let's have some fun, problem solving fun. What more fun than kidding have than that? 6 questions in 2 minutes. That's how we're starting now. That's how we're rolling now. 6 questions in 2 minutes. Let me get this thing set up. So I switch to that screen, and ooh, that looks ugly in the corner there. That is my clock. That is not set up as a clock. Let me fix that. Ooh, that's a live glitch there. What's going on there? What's happened to the clock? Right. I got the timer. Let's bring the timer back in. It's gonna happen. This is a side effect of doing things live, isn't it? Right. Okay, we got the 2-minute clock there. Let's make the 2 minutes visible. And then, are you ready? Sorry. Settle down. Settle down. I'm going to press the button. Let's go. Clock is on. First question is up. Six of them. Should do it myself. Next question. Next question. Last question. 2 parts. Okay, that is it. That is it. That is it. That is it. It is my turn now. Press OK. Timer. Bye-bye, Mr. Timer, and let's get going. So, how did you do? How did you feel? Do you think you got 6 out of 6? That's roughly the spade. 11 plus, you want to go to grammar school in the UK, highly selective schools in the UK. You got about 30 of these to do in 10 minutes, so it's about 3 a minute is what you need to be averaging. That's in one of the tests. There's different designs, all sorts of things people come up with in terms of testing. Right, calculate 309, take away 198. You've probably realized that actually this, you know what, I'll do this one slightly differently. I was going to go for the number line, but my mind looked at it and I thought, okay, what am I doing? What am I doing here? 198, you're taking away, you have 1. 9 take away 8 is 1, and then I would just do 30 take away 19 to give me 11. So 30 tens take away 19 tens gives me 11 tens, so 111. Your first answer, 111. Did you have that? 111. For the second one, a lot of noise. There's a lot of noise in this question. It's like, whoa, we're interested in stars. No, there ain't no star, no star. We're interested in stars, stars. And you get the idea. I mean, they're hinting after the circle comes a star. After the circle comes a star. So we know it's going to be 11 is there. So we wanted the next two numbers. You want the, I'm going to underline. The question is, what is the next two stars? By the time you get here, you see, or you should be seeing, it's 1, 6. Those are the two numbers you have. The difference, you were adding 5. The next number is 11 after you add 5. And then the next number is, ooh, you're not going to see that, but I'll put it in there, 16. So the other number, no, it didn't fit. I thought I would have made it, but I didn't make it. All right. So the pattern you were seeing, 1, 6, and then two numbers you needed to add, 11, and then 11 and 5 would be 16, because what's happening every single time is we are adding 5. Add 5, add 5, add 5. That's what's happening every time. 1, 1, 2, 3, 4, 5. We added 5. 1, 2, 3, 4, 5 for the next. I was gonna draw a star, and that is like so not gonna. No, I will show my artistic skill. Oh yes, I will. That didn't come out very well, did it? Let's stick to the maths. Let's stick to the maths and not the art. How about that? Whee! All right, the next one. This, I kind of like these kind of questions, and this is like actually a part A from a question with more parts. So I'll bring up one of the other parts later on in another problem-solving set. But from a SATs paper, Key Stage 2, end to end of primary in the UK. They have 16 cards each. Tom gives Nadia 12 of the cards. So let's see. We have Tom and we have Nadia. Oh, that is so not. What's up with me? I'm only trying to write behind my face. That doesn't work, and I'll just do it down here. How about that? I already have the names, so it makes some sense there. Reduces the need for you to see my I call it doctor handwriting. You know what that means. Woo! Right, both of them started off with 16, so 16, 16. Tom gives Nadia 12 of the cards, so Nadia gets 12 additional cards. She now has 28. That means he loses 12, so he now has 4. So Tom now has 4 cards, and Nadia has 28. They still have 32 overall. 32 cards, that's what we're looking at there. And then number... That was the fourth one. 1, 2, 3. No, 3. Yeah, we have. Yeah, 1, 2, 3, 4. Yeah, the next one. I think this is number 4. I'll be honest. I lost myself. I know the last one. I should have numbered it. That would have been useful. Second place. Second place. You're looking for the shortest. That was tricky. Normally, first place is just looking for the shortest time. Shortest time. Yeah, if you win the race, it was the shortest time. But we wanted the second place. So. And we're looking at 100. Look, I was getting myself in trouble. I was looking down here on the 800 meters. It's the 100 meter race. So make sure you're looking at the right data set. It's the first column. 100 meter race, the shortest time. So the person who came first was Elise. And then in second place, it would be Terry. So who finished in second place? It would be Terry in 16.8 seconds. 16.8 seconds. Third place is Neil. Then we have Barry, and then Jake. Let's just say it didn't quite work out for Jake in the 100. Did he do better? Yeah, you see what happened? Jake, it didn't happen for him in the 100 meter race, but yeah, he did better. I thought he won, but no, he came second in the 800 meter race. So clearly long distance is his thing. Right. Next one. A bottle of lemonade. Won't that be refreshing now? Weather like this, exactly what you want. Lemonade. Oh yeah. I love you know what? I was gonna say I love lemonade, but I just remembered. Trip in Portugal. This is like maybe 5 years ago. I was just moving around public transport, the trains and stuff, and just seeing different parts of Portugal. And no, it wasn't. I was doing a tour, which are Europe by train, and no, it wasn't Portugal. Sorry. It was Hamburg, Germany. And bought lemonade. I got a glass of lemon. I don't know what I don't know how much water was put in the thing, but it didn't taste like it had much water. And my goodness, there was no sugar. It was I don't know what went down there, but let's just say it. Yeah, the lemonade. No, nah. That was a memory. That was a memory there. Shall we get back to the maths? Let's get back to the maths. 1 liter lemonade. She fills 5 glasses. So she's doing 5 glasses of lemonade, 150 in each glass. So got 150, 150. That's 300. Another 2 glasses. That's another 300. So 4 glasses. I'm talking about 2. So 4 glasses are gonna have 600. She wants 5 glasses, so another 150. So the 5 glasses will be 750. That's sort of how, or you might have just done 15 times 5 is 75. But not everybody's comfortable with multiplication. So I'm just showing you, you could just keep adding and you'll get there. So 5 glasses at 150 each is gonna give you 750 ml. 1 liter is 1,000 milliliters. So what's left? 1,000. You need to take away. You need to take away the 750, which means you're left with 250 ml in the bottle. How much is left in the bottle was the question. How much is left in the bottle? It's going to be 250 ml. 750 from a 750 ml from 1,000. So 250 ml is your answer there. 250. And the very, did I get it right? Last one, we went to the wonderful world of algebra. Algebra, simplifying expressions, one of the earliest things you learn in algebra. We don't, first thing, hey, I don't know what K is. We don't have enough information to find out the value of K. So this whole thing, I've heard it. I've been doing this, what, 10, 15 years. This whole thing about, sir, what's X? Sir, what's that? I don't know what it is. We don't need to know what it is. All we need to know is if I have 5 K's, whatever number it is, I have 5 of them, then I have another 3 of them. That's 8 of these numbers, 8 K's in total. So and then I have to add on 7 more. So 8 times whatever number K is, I have 8 lots of K plus 7. That's all. 8K plus 7. You can't do anything else. And then in the second one, this is always a tricky one. K. If I said I have K, I have a K, a number. I don't know what the number is, but I got a number. How many lots of the number do I have? If I wrote down the number, I have 1 of it. If I wrote down the number, I have one lot of it, one instance of it. So I have 1 K and another K. That's 2 Ks in total. I got 2 Ks in total. Double the number. That's what K plus K means. Double the number, whatever it is. Double means to multiply by 2. In algebra, when we put the letter and number together, it means to multiply. That's the idea there. And then in addition to that, I have 1, 2, 3, 4, 5. So 2K plus 5 is your second expression. The first expression, 8K plus 7, not second, the first one, 8K plus 7, and then B, 2K plus 5. That is what we have there. Now, that we are sorted. Did you get all right? Way, you did all right. You did all right. Good stuff. Good stuff. Let us get on to... I got that geometry problem for you to do. I promise that was one I wanted to fit in yesterday from its past GCSE exam paper. But before we do that, I had this special as well. So I want you to look at this. Try this one, please. Try this one, please. Have a look. Have a go at it. Have a go at it. I'll make some notes here. And I'll underline key terminology. Yeah. Okay, you got something there? Now, remember, you can use the power of the pause. If it is that you want more time to think about this problem, you just press the button, the video will stop, and you got your time. If not, I'm going to go through it. I'm going to talk about it. And the idea, calculate the difference. So the difference, anytime we see that word difference, we need to remember it's the answer to a subtraction sum. The answer you get after you do a subtraction, the biggest number take away the smallest number. That's the difference, okay? And I say biggest take away smallest because generally when we deal with difference, we're dealing with a positive value. So what's the difference between 3 and 4? 1. Okay? Don't go difference is -1. No. It's the biggest takeaway smallest is what we'll expect you to do, and it's the answer to a subtraction problem. So, and then the other concept you need to be aware of here is perimeter. When we talk about the perimeter of a shape, in this case we have two shapes, a hexagon, 6-sided shape is called a hexagon, and a 4-sided shape is called a, what am I saying? I saw 4 triangles and I'm saying 4-sided shape. Woo! And a triangle, the triangle on the right, 3-sided shape. Now, if we want to calculate the difference in perimeters, perimeter is the distance all around the shape. So if I started at this point and I went all the way around, whee, and got back there, following the path on the outside of the shape, that's the perimeter. So the distance all around the shape. And if I use that logic, what I would see is that, well, I follow 1, 2, 3, 4, 5, 6 units. I don't know what the units are, but I got 6 of them going all the way around the hexagon. So I will say that the hexagon, the perimeter is 6 units. Now, if I look at the triangle, it's 1, 2. Yeah, we're joining up. We're every length, every connection on the dot. That's what I'm counting. So, one dot to the other. It's isometric paper, so it works. It's all the same distance. This is the distance from this dot to the other dot, this corner to the other corner, or vertex to the other vertex. That's the same distance. So 1. I'm doing the same thing here. I went from one dot to the other. That's 1. One dot to the other. Another 1. So 2. Then 3, 4, 5, 6. Did that just happen? Oh yes it did. Oh yes it did. The hexagon has the same perimeter as the triangle. Yeah, I did that. This is actually a mod. I changed this question. I need to put it as a modification by me. Make my notes. And 6 takeaway. 6 is a big fat... Yeah, the difference between the perimeter and the triangle and hexagon is 0. There is no difference. They are the same. Oh, I like that. I like that. That was fun. I enjoyed that. Did you enjoy that? Yay. Did you get 0 and were you thinking, you get the 0 and you start thinking, can't be 0. It has to be so. Why would they ask me to calculate the difference if it's nothing? Yeah, we can do that. We can do that. That's fine. And 0 is the answer. Right, now, let's check out some geometry. We don't really do a lot of geometry because at this stage, at this level, it's really more about our understanding a number. But we need to, and a bit of probability is important, and we do need to know our angle facts. So this is one just to bring back to this key idea. Do you know your angle facts? All the angles in a triangle add up to what kind of triangles, that's the sort of thing you're looking at. So I'll give you a moment to think about this question, this diagram, start working on it, then I'll get involved. And no, this is not the special for today. The special comes after. We're going to get that done as well. So think about this one. By the time I finish making my notes, I'll start going through it. Okay, so I'm here. I'm with you, doing the question with you. I'm telling you, we're in this together. All of us are in this together. That's what I'm saying. Right. Okay, I'm take some notes first. That's the first idea. When you add up all the angles in a triangle, you're supposed to get 180 degrees. So if I look at this kind of question, the bit you have 20, but you want to find x, but before you can find x, you need to find this angle down here, which we'll call y. And the thing you need to is, we know x plus y plus 20 is 180 degrees. And then the other bit you need to keep in mind, I'm just going to draw a picture now. I'm still giving you time to work on the question. I'm conscious of time, right? The second fact you need some of the angles on a straight line. So that straight line I have here, when you add up the angles on a straight line, it's 180 degrees. That's another fact you need for this question. Okay. And then look at what I'm doing there. Same base angles. So the other key fact you need, and now I've put enough there to finish the job, is that this triangle here, DBC, you can name a triangle using the letters. So if I go from D to B to C, D to B to C, that's a triangle. So I can say triangle DBC is isosceles. And I know it's isosceles because, well, it had those two lines there, which indicate that the two lengths are the same. And if those two lengths are the same, then the base angles are down here, and those angles are going to be the same. And I know that the angles in the triangle have to add up to 180 degrees. So that's the big idea. You have the power of the pause now to contribute to, if you want to finish the job. I'm going to start doing the job now. Then let's go through this. Okay, so what would you have? First, you want to find x. You can't find x because you need two angles to find the third. You know the angles in the triangle, so DAB. You know the angles in the triangle will add up to 180, but it's not going to happen. You're not going to get that 180. You're not going to get that 180 here. Okay, so we can't find it because we only have one angle to 20. So I need to find this angle y. It's on a straight line. If I knew z, this angle here, then I could find y. Isosceles, bottom angles have to be the same. Whole triangle is 180. So what do I do? The first thing I do is calculation number 1. I'm to find z. I'm going to do 180, take away 50, which will give me 130 degrees. That means these two angles, the two base angles are the same. Both of them have to be summed to 180 degrees. So that z is going to be 65. Let me write it down. It's going to be 130 divided by 2. We need a bit of space there. 130 divided by 2 and 130 divided by 2. That is going to give me 65 degrees. So angle Z is 65 degrees. That's what we have here so far. We use the properties that, let's see what we did there. It's an isosceles triangle. We had 50. If we take away 50, we'll get the two angles below 130. So I have that 130, half it, you'll get z. So I now know I can put that in my diagram This angle here is 65. Let's put it in green. Stick with the colors. Stick with the colors. This is 65 degrees. That's 65 degrees there. Now for the second bit, I can find y. And to get y, what I'll have to do is 180 take away 65. That's because they're on a straight line. Straight line is 180 degrees. So 180 take away 65, which when you work out, you'll get 115 degrees. 170, 80. 150 degrees. So I now know this angle is 115 degrees. And at that stage, it's game over for finding x, isn't it? Because we know we have 115 and we have 20. So that means those two angles together, that's going to be 135. Let's pop it in for our third piece in the work. 115 plus 20 equals 135 degrees. And what that means is that x, and I'm looking around, you know, space on the screen, my goodness. X, can I fit it in there? Yeah, we'll fit it in there. X, the answer to x is going to be 180 take away 135. 180 take away 35, that will give me 45 degrees. 45 degrees. So x, angle x is 45 degrees. It's half of a right angle. Half of a right angle. And that's the process we go through. So a lot of work to pull off on this one, recognizing, and these are the big ones. This is what determines if you get a grade 5 in GCSE exam, so a good pass in a GCSE exam in the UK. And I'm saying, and what I'm pushing is this whole big idea that our best talent, you, can get that grade 5. You should be operating at that grade 5. End of year 8 to the latest, end of year 7 can have that done. That's sort of the speed that I want to be, or the depth I want to work with young people to develop. It's not that case for everybody, but for those who are going to go on to be our top engineers, top scientists, you know, who are in love with maths and you want to do something related to maths, that's sort of the trajectory that we want. We have, I mean, wow, I've used so much time. We got 3 minutes more. I'm thinking, it's not going to be right for me to do a big one on this. Time has slipped away. I'm thinking, what am I going to do? I'm not going to do the question, but I'm going to put up the next question. The question that will start after we do the 6 tomorrow. This is the question I want you to think about. So you have, I'm just going to say it. I'm not going to do it. I'm not going to comment anything on it. But that is the question. I wanted to do it now, but I don't have time. It's going to be wrong. But if you want to start working on that, yeah, start working on this. See if you can figure it out. And tomorrow, this is where it's going to begin. I will actually sort this one out tomorrow first. And then do the 6. Or I might do the 6 first, for the 6 questions first. I'll decide on that. But yeah. I can't do this justice in a couple minutes. That will be unfair. So here you go. Big question for you to try. Work out, find A and E. A plus E. It's a nice one, isn't it? It's a nice one. I like this. I like this one. Okay, right. So I'm going to leave you with that. And yeah, I think this might be the first time I'm finishing under 30, but I think that's the right thing to do. So you pause the video, work on this, have it ready. So I won't give any time to work on it tomorrow. Tomorrow we'll just get going, get stuck in with going through it and cover some more. All right, take care of yourself. Bye-bye from Mr. D. Go on, enjoy the sunshine after you finish. Deal with the question now.